All right, geometry. We are moving on with parallelograms to specific parallelograms. First with rectangles, then two others we'll get to. But with rectangles, you'll notice all of the characteristics of parallelograms apply here. Okay, so with that being said, all of their opposite sides are congruent and parallel, just like before. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. So all of that stuff is the same. Now, for rectangles specifically, we have two things. First of all, as you already know, rectangles have right angles. So all four angles are right angles. Okay? And also, since it's all the same, you can kind of look at here, since all the sides are the same and they're right angles, that makes the diagonals congruent. So the diagonals are the same, or congruent. Okay? So, with that being said, let's look at a few of these. Okay, so for number one, just as before, opposite angles, or opposite sides, are congruent. So QR is 10. 24 means this is 24. SR is 24. Now, with that being said, there's a theorem that we've used before in geometry that we're going to use quite a bit with polygons, which is the Pythagorean theorem. So before, anytime you have a right triangle, you can use the Pythagorean theorem, which says a squared plus b squared equals c squared. Okay? So a squared plus b squared equals c squared. So if that's the case, to find SQ, we can say the two sides, so 10 squared plus 24 squared equals SQ squared, or I'll just call it x squared. Okay, so that's 100 plus 576 equals x squared. So that's 676 equals x squared. And I take the square root, and I get x equals, and I got to use my calculator. So square root of 676 equals 26. And so that means SQ is 26. Okay? And since the diagonals are equal, that means PR is also 26 because the diagonals are congruent. And QT is half of the diagonal, which is 13. Okay? So you might have to use the Pythagorean theorem. That's just a fact here. So same thing on number two. I've got 15 here. Okay, so that means this is also 15, which means the other is 15 and 15. So AC, the whole thing, is 30 put together. BD is also 30. BE is half of the diagonal, which we said is 15. AB, we'll find out in a second. Oh, wait, AB is opposite of DC. Didn't see that there. That's 27. And then BC, we're going to have to use the Pythagorean theorem again. So BC, 27, and the hypotenuse, 30. So this time the hypotenuse is 30, so x squared plus 27 squared equals 30 squared. So 27 squared. Again, I'm going to have to use my calculator for 27 squared. I don't know what that is off the top of my head. 27 to the second power equals 729. So 729 equals 30 squared is 900. So 729 x squared equals 171. So take the square root of 171. Square root of 171. And it equals about 13. So 13 or 13.1, whatever. Round to the nearest depending. Okay? So, moving on to angles now. Okay, so again, think about opposites here. So, if this is 27, opposite is going to be across the diagonal, which is here. So that's 27. Well, if this is 27, remember the diagonals are equal. So that means their opposite angles are equal, which means 27 is going to be the case for all of these inside angles. Okay, so if you have an inside angle, all the inside angles are congruent, and then the others are just whatever makes 90. So 90 minus 27 is going to give us 63. So this is 63, this is 63, this is 63, and this is 63. So we can kind of start to go from there. So MJK is the whole angle there, which is 90. MJL, however, is right here, which is 63. JLK is right here, which is also 63. Oops, not 62. KML is right here, 27. And an MNL is right here, which we haven't found. But look at the triangle that's created. Again, triangles can be used a lot. So if you have a triangle, we know that adds up to 180. So 27 plus 27 is 54. So 180 minus 54 is going to give us that angle. So 180 minus 54 is 126. Okay. So again, you can kind of see the benefit of labeling as you go. Okay. So same thing here. This is 64. So if that's 64, these two have to be whatever's left out of 180. Well, 180 minus 64 is going to be 116. And so if it's 116 for two angles, you got to divide that by 2, and that's 58. So this is 58, this is 58. Okay? And so if that inside angle, 58, 58 again, and making 90, the other part of those angles would be 22. Or not 22, sorry, 32. So 32 here, 32 here, 32 here, 32 here. And then the other, well, let's see what we're looking for. XWY would be 58, like we said. YXZ, I'm going to label these as we go. YXZ would be here, so that's 32. WVZ is right here. Now, either take these and subtract 180, or look at 64 and that angle. That makes 180, so that'd be 116. XWZ is the whole angle. That's 90, obviously. And then XZY is right here, which is 58 again. Okay, so that's how you're kind of looking at these angles as you go. Okay, so for these other examples, kind of depends where they're at. Okay, opposite angles, we would set these equal to each other to solve for x. But just make sure we're plugging back in to find the rest. Okay, same thing here. RT is the diagonal, so is US. So those should be equal. So I can set those equal as well. Okay, so let's actually do this one. 5x minus 14 equals 2x plus 10. So I'm going to subtract 2x to one side. 3x minus 14 equals 10. Add 14 to get y or x by itself. 3x equals 24. Divide by 3, I get x equals 8. Well, it didn't say find x. It says find VT. Well, VT is only part of the diagonal. So I need to plug it into RT. Okay? So when I do that, 5 times 8 is 40 minus 14, which is 26. That's the whole thing, though. So half of it is just half of 26, so VT equals 13, half of 26. Okay? So as you look at these, you got to really pay attention to what we're looking for. So JM is half of that. MK is half of that. Well, if the diagonals are the same and they're both half, again, you can set these two equal to each other and then solve for x, plug it back in, and you'll have to double that. So number 9, VW is right here. SU is the whole thing. Okay, so if this is 9x minus 11, the whole thing is just twice that, which is equal to 16x plus 12. So I can really just go twice 9x minus 11 equals 16x minus 12. So that's 18x minus 22 equals 16x minus 12. Get x on one side of the equal sign. I get 2x minus 22 equals negative 12. And now we solve. So 2x equals 10, and x equals 5. So if I'm looking for WT, well, I already know WT is the same as VW. So I'm going to plug it in to there. 9 times 5 minus 11. So that's 45 minus 11. So WT equals 34. There we are. Okay. So the last four here, kind of just depend. So again, these two are opposites, so set those equal. And then BCE is just whatever is left out of 90. Okay. Same thing here, but these are right next to each other. So this one and this one add up to 90. So I've got 3x plus 2 plus 12x minus 17 equals 90, and go from there. So 15x minus 15 equals 90. Add 15. 15x equals 105. Divide by 15, x equals 7. Well, again, look, JHI is up here. And I know that's opposite of this one. So I plug that into here and get my final answer. 21 plus 2, angle JHI equals 23 degrees. Okay, so that's rectangles. Those are the things you want to kind of look for as you go through and solve different parts. Okay, now we'll talk about square and rhombus next.